Today's video is going to cover lesson 3.4 exponents with multiplication. It should be page 28. We're back in cluster 3. The goal for today will be to use the product rule of exponents to simplify expressions. A couple key terms today. Actually just one, the product rule. So the product rule can be used to add the exponents of same bases when the bases are being multiplied. So this is a special property that is only applies to exponents. And below you can see that there's two examples of what this product rule is. We've got a concrete example and an abstract one. So in this concrete example, you can see that the base is 3 and the bases are being multiplied. So what we can do is we can go ahead and add the exponents 4 and 2 to get 6. And we can say that 3 to the 4th power times 3 to the 2nd power is the same thing as 3 to the 6th power. And that makes sense to us because we know that the exponent tells us how many times the base is being multiplied to itself. So here we've got 3 being multiplied to itself 4 times. And we've got that being multiplied to 3 being multiplied to itself twice. Well, how many times total is 3 being multiplied to itself? Well, total, it's being multiplied 6 times. So that's why the product rule works. In the abstract sense, we've got a to the m power times a to the n, where the bases are the same and they're being multiplied. So we can say that a to the m times a to the n is the same thing as just a, and we're adding m plus n for our exponent, right? So an example of the product rule not being applied correctly would be if you had, let's say, 5 to the 3rd power times 6 to the 3rd power. You can't say that you have 5 to the 6th power, because 5 is not being multiplied 6 times, it's being multiplied 3 times, and 6 is being multiplied 3 times. So here the bases are not the same. That's when you cannot use the product rule. So just make sure your bases are the same. Let's go ahead and get into example number 1. Example number 1. The first step with these problems is to identify the number of bases. So how many different bases do we have? Well, we've got one base, and then we've got a constant. These numbers are constants. So the second step will be to add the bases. Add the exponents of like bases. So the like bases here are x, and the exponents are 2 and 5. So we can say that x times x is just x to the 7th, right? And the third step here will be to multiply the constants. So we've got our constant right here of 3 being multiplied to a constant of 4. Well, 3 times 4 is 12, and we can just write that in front. And this is our final answer. Now there is a fourth step. The fourth step will be to order properly. And when I say that, what I mean is A, B, C order. But since we only have one exponent, or one variable, there's nothing really we can order. Example number 2. So our first step is to identify the number of bases. So we've got an x base and we've got a y base. And it's clear that they're being multiplied, so we can go ahead and add the exponents. So for our x base, we've got 4 plus 5. And for our y base, we've got, there's no number here. When there's no number, we know that it's a 1. So if it helps you, you can go ahead and write a 1 right there. we've got 1 plus 2. Now we can go ahead and simplify this to x to the 9th and y to the 3rd, and you can see that I've already got it in ABC order. And now we can go ahead and multiply the constants. We've got a constant of 2 and a constant of 3. So 2 times 3 is 6, and we always write the constant in front. Now if I'm putting this into Schoology, I would have 6 x to the 9th power times y to the 3rd power. That would be my Schoology answer. Example number 3. So I'm going to identify the number of bases. We've got an x base, we've got a y base, we've got a z base, x, y, and z. Now I'm going to go ahead and add them together. So we've got 0 plus 4. There's no other x's. We've got y is 2 plus 3. And we've got z as, again, we can put a 1 right here. 1 plus 4. And then we can go ahead and simplify this. So 0 plus 4 is 0. Or, sorry, 4. 2 plus 3 is 5. And 1 plus 4 is 5. And our constants here, we've got a 3 multiplied to a negative 2. 3 times negative 2 is a negative 6. And this would be the final answer here. Example number 4. We've got a base of B, base of A, we've got an A base, we've got a C base, we've got an A base, a B base, and a C base. Then we've got our constants, which we can go ahead and box now. And this is all being multiplied, so we can use the product rule. So first I'm going to write my A base because that comes alphabetic before B and C in the alphabet. We've got 4. Cross this out, that way I know. We've got 1 right here. Cross that out. And we've got another 4. Cross that out. Now for our B's, we've got 3. And that looks like a 41. And for our C's, we've got 5 plus 7. So we can go ahead and simplify this. We got 4 plus 1 is 5, plus 4 is 9, so we've got a to the 9th. We've got B, 3 plus 41 is 44. And we've got C, 5 plus 7 is 12. And then our constants here, we've got 3 times negative 2 times 4. 3 times negative 2 is a negative 6. Times a 4 is a negative 24. So our final answer is negative 24, a to the 9th, b to the 44th, c to the 12th. Last example for today. Let's go ahead and box the constants. We've got j, we've got a base of k. Whoops, should only use 2. I guess it doesn't really matter as long as I keep it the same. Base of p, p base, k base. We've got a maybe I should box this negative because it's a constant technically. And a negative 2. We've got j, and we've got p. Okay, so we've got a 9 times this negative is a negative 1 technically, times a negative 2. We've got j, we've got a 3 plus, any more j's, we've got a 7, we've got our k, and I'm putting them in alphabetical order. We've got 71, we've got 3, now we've got our p, which is 4 plus 5 plus 9. So everything's been accounted for. We've got our constants being multiplied, and we've added up all of our exponents. Now we can go ahead and simplify. So we've got j to the 10th, we've got k to the 74th, and we've got p to the 18th. 4 plus 5 is 9, 9 plus 9 is 18. Now we can go ahead and multiply our constants. We've got negative 9 times a negative 2, which is a negative 18. So our final answer here is negative 18, j to the 10th, k to the 74th, p to the 18th. I'm going to do one more example. This time I'm going to show you what it looks like on Schoology. Let me erase some of this so I have some room to write. Okay. So here we have simplify the expression, type in alphabetical order. So when I look at this, I've got the constants of 4. Looks like I'm going to have to do this without. I've got a constant of 4, and I've got a negative. I've got m, and n, and p. So my p's, or I'm going to do my constants first because that's going to come in the front. So I've got 4 times a negative, which is a negative 4. Now my m's come before the other two letters in the alphabet, so we've got m to the, we've got 3 right here being added to, there's no number right here, so we know that it's a 1, so we can say 3 plus 1 is 4. We've got n to the 5 plus 8, 5 plus 8 is 13. And p to the 0 is actually 1, if you remember. So you can go ahead and write that in your notes. Anything to the 0 power is 1, except 0 itself would be 0. So because this p has no other number to add it to, p to the 0 power is 1, so we don't write it. Because 1 times negative 4 would still be negative 4. That would be my answer in Schoology. Good luck on the homework.